Thanks, Asek, for introducing me. And thanks, everyone, for coming back from the back. So today I'm going to talk about Android application backdoors using Appium. And as you can see in the title, it's going to be very Android-specific talk. There is nothing related to iOS in this, but I'm happy to talk about it after my talk outside. This is me. My name is Rajdeep. I've been doing UI automation from last 9 years now. I've been a contributor to Calabash Android project, both the client and the server side. And I'm author of some of the open source utilities for improving the automation. And I recently started using Appium at Badoo. That's the place where I work. So Badoo is basically a dating platform, and we have lots of dating app. And as and when we get chance to automate new app, we try different tools. So for one of our applications, I started using Appium. And being a Calabash user, by the way, anyone here have used Calabash? Yeah, that's an odd question to ask at Appium Conf, but still. There are quite a few people. So yeah, when I moved from Appium, or started using Appium, being a Calabash user, there is one very important feature which is in Calabash but missing in Appium, and that's what I'm going to talk about today. So let's get started. How many of you have played this game? Please raise your hands. Those who have not, probably they are way too young. So this was a favorite game of mine when I was a kid. I used to play this game a lot. It's called Contra. And I used to love this game because I always used to win in this game. I used to compete with my brother, and I used to beat him in this game. And the reason was not because I was very good at playing this game, but I had unlocked a secret of this game. And that secret was this. Up, up, down, down, left, right, left, right. Can anyone guess what is this? Yes, you said right, but in popular gaming world, it's called cheat code, right? And if you know cheat code for a game, you are basically master of it. So as soon as you key in these key combinations, I get 30 lives, which are basically good enough for me to beat my brother. Yeah? So this is a cool thing. Basically, this gives ultimate powers to us, right? Like you can do whatever you want if you know cheat code. And this analogy is very similar to some of the things which we use in our day-to-day life. For example, if you are an Android automation engineer, you can go and unlock your developer options, where you can actually alter your CPU speed. You can play with the activity lifecycle using don't keep activities. How many of you have done that, by the way? A lot of them, right? So basically, that is a kind of a cheat code which Android operating system is exposing to you, right? If you're a manual tester, sometimes the developers of the team give you these kind of debug menu options, wherein for debug version of your app, you can open a secret menu from which you can probably change your backend URLs or mock some data in the app, and that's pretty good, right? So that's about manual testing. How about automation? And do we need it for automation? So let's take some example why we need cheat codes, or I'll bring the word backdoor here. Why do we need it for the automation? I'll introduce backdoors later on, but let's see some examples. I'm going to use the F word here, and this is flaky app. So many a times your test automation is running, and there's a random pop-up which says, please give us feedback or rate us, and your test fails. And then you have some fallback mechanism of the rerunning test, and that's how we usually solve this problem. But this pop-up is very random. Like, it's unpredictable. It can show up at any point in time, and it's not your test's fault, and your test cannot control when this will be shown. Now imagine if your test could tell your app, hey, I'm testing you, so please never show this pop-up again. Now, another example. That's the problem number 2, which is about driver limitations. Yeah? So not everything can be automated using our contemporary drivers like APM or Calabash. So for example, you want to shake the device for some feature, or maybe let's say you are testing an alarm application, and it has a feature when you flip your phone, the alarm should snooze. Now, how will you test this feature? One way is to ask Jason Huggins to build a robot for this. But yeah, this is something impossible to do with APM. Like, how will you do this? Now, imagine your test code could tell your application, like, I'm testing you, I want to shake the device, assume it has been shaken, and please move on. Another example of the same time, let's say you are testing an application, which is a weather application, and the weather refreshes every 30 minutes. And you want to test this business logic of after 30 minutes, the weather is refreshing. Now, how will you test this case? Will you wait for 30 minutes for the weather to refresh in your automation? Obviously, no. So imagine your test could tell your app, like, for some time, can you please make this 30 minutes to 3 seconds so that I can test you properly? And last, but a very big problem is, our tests are very slow. So at Badoo, we have lots of tests, like almost 1,200 tests. And for each test, we need to log in, like enter username, password, click on the button, which takes 30 seconds, right? And there is another 30 seconds wasted in dismissing the what's new. You tap next, next, next to dismiss this onboarding screens, which basically wastes 1 minute of your test run time. And I don't want to repeat this again and again in each test. Now imagine your test code could tell your application code, can you just log in with this token and don't show me anything related to what's new because I'm not interested in it for this test. Now that brings me to the point, like what if your test code could actually communicate with your application? And that's basically the concept of backdoor. So imagine you have an Android application, and it has an activity, let's call it login activity. And you can define a method, a public method, let's call foo. And in this method, you can write the logic to shake, to mock the shake functionality or flip to snooze, or probably to disable the what's new or the random pop-ups. If you could do this, and imagine you could call this method from your test automation code base. Now, I use a lot of Ruby. This method is in Ruby. So let's say you can write a method in your Ruby automation code, APM test automation code, saying invoke foo, and you call backdoor and the method name. And somehow this method magically gets called, and something happens, which is like all the things which you have written in the foo just comes alive, and your problems are solved, right? Now let's see it happening in action. So I'll show you a quick demo. So for the demo, I have got a very simple application. Can everyone at the back see this emulator and read the text fine? OK, perfect. So let's say in here, in this application, I have a text box which has some text, which says love APM. And I have some buttons to make the text bold, or for example, if I click it, the text goes bold. I click this one, it goes italic, and I can increase the size, right? What I want to show here is these are the styles and attribute of the text. For example, verifying the size, or is the text bold or not. Can we do it using APM? At present, the UiAutomator tool driver doesn't have these kind of APIs. And I'm going to show you we can do it using how we can do it using backdoors. Now, in real life, you probably would not want to do this. Using APM, you might want to write a unit test for it. But just the sake of showing a demo what is the power of backdoors, I'll demonstrate this. So here is the code for this application. On click of the button, what happens is being handled on these methods, which says on bold, on italic, or on increase size. Now, if you observe, there are two methods which are like gray. The first is raise toast with message, and second is message view. They are gray because they are not being used in our code base anywhere. And they are here because we are going to use them from our automation code. So the first one says raise toast with message, and it just does nothing but raise, shows a toast message with some message which is given. So this method takes one string parameter, right? And now we'll call this method from our automation code. I'll show you my automation code, but before that, so my automation code is just a simple Ruby script. There's nothing fancy in it. And I'll run this test. It's just basically a single Ruby file, and the test will run. There's nothing fancy about it. Probably everyone in here has seen an APM test running in before. And this is the automation code. I simply just create a new driver, start the driver, and then there's a pry debugger. Basically, this is a debugger point which will halt in my console. Can everyone at the back see the console? Yeah, perfect. So here, I'll call the method which I showed you, which is this, raise toast with message. And I have defined a method called backdoor. And all I need to pass this method is the name of the method which I want to invoke, and the argument which says args, and I say welcome. And you see there's a method has been called. Can everyone see there was a, I'll repeat it again basically. So there's a toast being raised. So I'm actually calling an application code from my automation code this way. Now, that's not much useful, but let's see the real use of verifying the text attributes. So now you see this message view is a method which returns me very simply the object of, or the view object of the text box, which is this text box, right? So I'm just going to get this, this object in my test code. So again, I say backdoor, name of the method, which is message view. And what you see here is a string representation of the object, which is, I'll highlight, it's called app compat edit text, right? Now, if you have used Calabash before, this is the same kind of output which you get from the query language. It's one of the field of the query language. So we got the object. Now, the cool part is we can invoke one more method on this object. We can keep chaining. So let's call more method. So if you look at the Android documentation of text view, there's a method called get text size. These are the official Android docs, right? So I have a text box text view object. I'll call this method again on my result. So I'll say this name, and on the output, I'll call a method whose name is get text size. And the text size currently is 54. And I'll increase the text size, and let's verify what happens. So I say increase. I click it a few times, and it is going to increase, and it's going to blow up. OK. So I call this again, and this time it's 93. So you can do these kind of verifications using backdoor. So this was a very simple example wherein I exposed one of the UI view using one method, but you can expose whatever you want. Like, it's your call. You can expose a code which can kill your application. So that's basically so powerful, right? So let's get back to the slides, and I'll share where we use backdoors in reality. So I'm a big fan of backdoors, and when we build our Android APK in our CI, we build only one artifact, and we test the same artifact against all environmental, whether it be staging or integration or prod. And we change the backend URLs using the backdoors. So we define a backdoor which changes the URL, backend URL, and we call it in the before hooks. Badoo is basically present in more than 46 languages, right? And we test our app in multiple languages, and there are different applications which we have built on top of Badoo to verify the locale. And if we keep changing the device locale and test this, it will be very time consuming, because changing the device locale and restarting the app is too much. We expose a backdoor which mocks the app locale to something which we give it, and it's just in a moment of the click. Getting some things back from the application. So for example, many of you might have this thing like CAPTCHA in your login forms, right? And if in our case, during our automation, we want to disable that CAPTCHA. And to disable that CAPTCHA, we need to tell our server, hey, disable the CAPTCHA for this particular session ID. And we get that session ID back from app using Backdoor. And as I spoke of earlier, we just completely disable what's new using backdoors. At Badoo, we do a lot of client-side A/B tests. So we release a feature with 4 variants, and any variant can get selected randomly, right? And if the test is in the not right variant, it will fail. So to make our test more predictable with A/B tests, we have exposed it using Backdoor, that we select this particular variant using Backdoor and test, which is more predictable. And faking some SIM card related parameters. Like there was, in one of the previous talk, it was shown that these are some of the impossible things, like you cannot have a Vodafone SIM card in Germany to test some of the payment page of your application, right? And it's a truly international application with probably in every country. So if we want to test some SIM card with some specific country, we mock it using backdoors. And last but not least, very important, is analytics data. So on every click, we send some analytics data to our server. What have we sent? We get it using backdoor. So we just keep it somewhere and call our backdoor, which gives us, OK, these are the parameters we sent to server. Now, that's very interesting how I did it. So let's have a quick look at the as-is architecture of Android side of Appium. The diagram might not be very good, but I'll try to explain my best. So yeah, so there on the client side, there are client bindings. I use Ruby, so it's like Appium client, that side, on the left-hand side. And then the WebDriver call goes to the Android device using ADB port forward. And in the device, there are these 2 orange boxes are 2 APKs, which basically drive your device. In fact, this is the one which has all the code, which is called the server APK. This is all the handling for the WebDriver endpoints, like all the click or scroll, everything is being controlled by this. So this has the code for the HTTP server. Now, the HTTP server it cannot be started by itself. To start the HTTP server, there is another APK, which is called the test APK, the first one. So the only purpose of the test APK is to start the server APK. And there's a reason behind it, because this test APK has just a single test, which has nothing but the code to start the server. And it's able to do it via instrumentation. So the instrumentation is Android support libraries, which basically provides some hooks in the process of the application run, and using which you can basically call, the process which are instrumenting are running in the same process space, so they can access each other's context. So the test APK can start server APK, and the test is run using ADB shell AM instrument from the UiAutomator to driver, which is not shown here. So once the server starts, the UiAutomator, using the UiAutomator to APIs, our application under test is being driven. Now, I wanted to implement the backdoor in this architecture, and obviously, coming from the Calabash side, I see that 2 APKs here are actually not needed. So what if we can modify this architecture to something like this? I merge both of these APKs into one single APK, right? So I merge all the server code, all the HTTP code into the test code, and I have only one APK, which means everything is in one. And using this one APK, I instrument my application under test, right? And if I can do that, I can basically put a hole into this. I can make a tunnel which can invoke the backdoors in my application. I can access the context of my application under test using the APM server, right? And that's going to be very cool. So I did the same thing, and what I did was, this is the as-is code of the UiAutomator 2 server. There are two blue highlighted lines. The first line is the test APK, which, if you see, has only one file, which has just one JUnit test. And the second highlighted line, which is the main folder, has all the handlers, HTTP, and basically all the WebDriver handlers. And I merged them both into one. And the main folder has nothing but just a manifest now, right? And everything else is in the test APK, the test and the server both, right? And this is already done in one of the fork, which which is in my GitHub. And then I added a special endpoint called Backdoor in this fork. And it looks like this. Sorry for the small fonts, but so I just add a new endpoint, and I call it Backdoor. And this is the code of how the backdoor endpoint is being handled. I get the activity. There's a code to get activity, and from activity I get the application. And whatever I post from my client to the server on the backdoor endpoint, I parse them, and using the reflection APIs, I find what are the methods available on this application class. And so this get backdoor operations is the method which looks up for the available methods which we have got from client using the reflection. And for each operation, we invoke that backdoor. So as I showed, we can chain the methods. So we can get the view and call get text size and call something else and even blow it up. So that's being done using this operation.apply. Right? Now, once we do it, we build with the new merged code. We build the apps, and we get this big name. It's not fitting the slide, but yeah, that's the name of the merged big APK, which has everything in it, which is quite cool. But there's a problem. And if you see this instrument pair still has the old target package. So every app, if it's instrumenting another app, it should say which app I'm instrumenting to. So there are two requirements for instrumentation to be successful. One, the manifest should say which app I'm instrumenting to, and second, the both apps should be signed with the same key store. Now here, the target package is still the UiAutomator 2 server, and we need it basically to our application package. We need it to be our application package, right? And there are multiple ways to do this, but the simplest way is I created a Ruby gem to do it, which is called APM Instrumental. And what we do is basically simply say APM Instrumental, the Ruby gem, because I work in Ruby, but it's possible to do in any other language. And I think APM Espresso driver, which is coming in, has something similar code in it. I say APM instrument my APK. Basically, this creates a copy of the same merged APK, but with the instrumentation pointing to our application under test, and also it's going to sign it with the same key store as our application under test. So we get two APKs here, and we should install them, and that's pretty much it. And on client side, we could say on the local host and the forward port, which is the UiAutomator 2 system port, and we post the data which is like the methods, name of the method, and arguments of the method. And we can repeat this any number of times for chained methods. For convenience, we can define a method like backdoor and the URL. And this is the method which I actually showed you during my demo. It's basically posting on the same endpoint with a pretty data, like well-formatted data. So yeah, that's how you will call it. You say backdoor and then name, method name, and arguments, and so on. So that's pretty cool. But there is a danger. Like, because it's so powerful, it can be misused, right? And it's so powerful that you will be tempted to use it a lot, and you will, in fact, do it wrong way many times. So I have a quiz for you to show this. So here is this quick quiz for you. So imagine, this is the example from our my first example. So imagine you have a weather application, and the weather refreshes every 30 minutes, right? And you want to test this. And I'll give you two options. You can do it using backdoors. The first option is you add a backdoor which will change the refresh interval from 30 minutes to 3 seconds. And you call it change refresh interval, and you can pass the time as 3 seconds. And the second option is you add a backdoor method which refreshes the weather, right? How many of you will choose the first option? Please raise your hand. OK. And how many of you will choose the second option? There are some people who did not raise the hand. Probably they. OK. So those who chose the first option are ethical cheaters. They are doing it. They are cheating, but still it's for the benefit. Right? And those who raised hand for second one, they are the real cheaters. The reason is because if you do this, you are basically bypassing the logic which you really want to test. And the logic is your scheduler should schedule a call every certain interval to the weather API, right? And with this second option, you are bypassing it, and you are making your test pass every time just because you want to show it to your manager that everything is passing. Yeah. So that's pretty much it. These are some of the references, and this was inspired by the Calabash, obviously, and I'm still using it. And so the next step probably would be, so all the views which we have in our application. So I showed you by creating a method and exposing it, but ideally, if done right way, we don't need to create those methods. The views can be accessed because they are in the context without exposing them. So we can do that. And I need to speak with the maintainers on how we can do it, how we can put it in the main APM project itself, because it's right now in my fork. Yeah, thank you so much.